Alrighty. That thing that I had this evening, I realized was canceled this week. So figured I'd hop on and get some more time in on the virtual memory visualizer. So just to refresh, this is where I left off. So we have the binary taking in a single positional argument for the PID, and then it loads the maps in from the PID. And I was thinking about it during my break here. Oh wow, that is a huge bunch of memory. But yeah, I was thinking about it during the break that I took. Like, how should I structure all this data? And basically, like, I want to, if we rerun this, I want to store page data, but only when it's needed. Like when you're at this level of the zoom, like we would have synchronization of the data for these 6 pages of memory. And then like as you zoom out, like once you hit like say you're at this level, maybe you have these 9 blocks, but once you hit a certain like zoom level, like right about here, where it's not even drawing the cells, then you just like stop synchronizing the data. Because like the data doesn't need to be synchronized between the 2 processes unless it's being drawn on the screen. So I was trying to think, like, how do I create a data structure that allows me to do something like that? And I kind of started thinking about this idea, which is basically how page tables are implemented in the kernel, where you have like a buffer of pointers. And then those are if you're not synchronizing any data, those are all null. But say you're synchronizing data in the, say it's a 64 element buffer of pointers to page table entries. And then one of those elements, say you're in the first 64th range of the address space, then you would go to that first pointer, the first element of the array, and if it's null, you would then create the page table for that. And then you kind of navigate down multiple levels. So in Intel, I believe it's 4 levels of page table entries. So you get down 4 levels, and then at the last level is the actual page itself. So that would be an efficient storage mechanism and traversal mechanism. So you would traverse down 4 levels every time. So it's like 4 levels of indirection. But because these page tables are close to each other, chances are you're going to be accessing the same page tables over and over again. So really those 4 page tables, because it's 4 levels, would be accessed over and over again. So they would be stored in the cache, assuming the page tables can be stored in the cache. So yeah, that's kind of what I was thinking, is just basically implementing my own version of a page table. That would be efficient storage. And then the question is, like, how do we turn off and on whether the page is being synchronized or not? I was thinking that's kind of similar to how pages are, oops, I need to disable idle locking. Give me 1 second here. That's super annoying. Give me 1 second here. All right, and then, all right. So I just did type in my password there. Let me disable locking here, which would be super control I. There you go. So where to leave off there? Oh, so how would we effectively disable and re-enable storage? Because you can imagine, like, if I was like in this level of Zoom and I'm synchronizing all the data for these pages, and I just keep on scrolling through huge areas of memory here, like, you'd want these to be unloaded from memory. You don't want them to be continually being loaded in memory. At some point, you want to swap them, basically. Or just stop synchronizing is fairly easy. You can just have a single flag. But how do you free the memory? So this is going to be a huge allocation. How do you then go through and free the memory? If it's not being synchronized, it's not being displayed on the screen. To do that, I was thinking we could have like a linked list. So anytime you add a page to this page table system, you also add it to a linked list. And then whatever process is monitoring memory and doing the synchronization will periodically check the linked list. And if something hasn't been synchronized because it's not visible, or if something's not visible, you just free the memory. It's like, okay, it's not visible, free it. So those visibility checks have to be done in the main thread. So the main thread will traverse the page table entries. And because these page tables are being operated on from multiple threads, you have to have some type of locking mechanism for them. And you want that to be somewhat fine-grained instead of like a global lock for the entire data structure. So traversing down, you probably have like a tuple at each entry. So you'd have the pointer for the entry, for the page table entry, and then you'd have like a mutex guarding it. Then you just have to acquire the mutex to perform the read, and then release the mutex, and then dereference, and then do that iteratively. And it's all in the same order, so you don't have issues with like thread A doing it out of order from thread B and having a mutual deadlock. So the ordering is good. Synchronization of the page tables is good. So the UI thread, the main thread that's doing all the UI stuff, gets down, it resolves to either there is an available page or there isn't. And if there isn't, does it do the work? Or does it tell the thread, hey, I need you to show me these page table entries? I think that's probably the better thing to do, is like the UI thread computes what pages need to be displayed and sends that data to the synchronization thread. And that synchronization thread then uses that data to either update or like remove page table entries, add page table entries and pages, synchronize everything, update all of its data structures. So basically the main thread is just telling the worker thread what it needs. And it can do that at the start of the thread before it does all of its drawing. And then as it's doing its drawing, it can do its reads. And if the reads aren't available yet, it can do like a try read or a try lock acquire. If it's not able, I guess it can attempt to perform the read. If the read fails for whatever reason, it can't acquire a lock, or I guess not acquire a lock probably wouldn't be a good reason to fail. these locks are intended to be ultra short-lived. So I would not expect it to be necessarily a try lock. But if the read fails for whatever reason, because the data is not synchronized or because there's not page table entries available, basically because the worker thread hasn't done the work yet to actually synchronize the data, then we can just synchronize. We can just display like a null, some type of special value that indicates, hey, the data hasn't been synchronized yet. And it'll do that, complete its loop, and then re-request the data to be synchronized, and it'll keep on going and doing that until the data is actually synchronized. It's not going to slow down and like wait for the data to get synchronized to draw a frame though. I'd rather draw frames that have like placeholder values for the data than to just not draw a frame. So I think that's the general idea of like how I want to synchronize memory between the two processes. So the first step is to did I do a commit here? I don't think I did a commit. Let's do a git status. So we add a bunch of stuff like args, debug, process h, did some modifications. So git DC, and then I'll do a, how do I do this? Like that? Yeah. Let's write a commit message here. So the things that we added were add arg parsing, process, I guess we can just say process state was part of arg parsing. Debug translation unit. This is map.h. So refactor maps. That was the big work done there. We'll say map registration. And then the main is just doing different stuff now. Read maps from PID. That was a big thing done there. It's map C. Okay. So the question I have is like, do I want to do a full virtual memory page table? Or do I want to have something a little bit more narrow and optimized for the problem at hand, which is like, we have all these pages in a map. How do we efficiently store data for that one page? And then we just replicate that for each map. That seems like it would be more efficient, but less general, and possibly more difficult to implement than just a generic solution for all of the entire virtual address space. I think the map specific one is attractive to me because it's less data that I have to deal with. There's less levels of page table nesting. The thing that's nice about the 4-level page table nesting is that like that is just like standard Intel architecture stuff. Like that's fixed in stone. Like that's not going to change. Whereas with the maps can be, anywhere between one page and like would be 48 minus 6. No, 48 minus 12. So that would be 36 bits, 2 to the power of 36 pages, I believe. If my math is correct there. So it can be anywhere between 1 and 2 to the power of 36 pages. I mean, practically, you would never hit that. Probably 2 to 35 would be the conceivable maximum there. But even so, like, there's a maps can be potentially very large. I guess let's ask AI. Say, hey, on Linux, AMD 64, what is the largest size of a map in procpid maps? See if AI knows off the top of its head. Can theoretically span almost the entire user. That's what I was calculating. For standard 4-level paging Linux kernels, user virtual address typically from 0 through that, which is 47 bits for user space, because the 48th bit is for kernel. So it would really be 47 minus 12, which would be 35, which is what I said earlier. So theoretical maximum size of single VMA virtual memory area map entry is just under 128 bytes. Example, maximum looking map. Like you can't use 2 to the power of 47 because that's how big it is, but it's divided by 2 to the power 12 because of the page sizes. With 5-level paging enabled in newer kernel CPUs, user space newer CPUs allow for 56. Shared libraries, guard pages, mmap-based randomization, kernel split, and VMAs cannot overlap. With 5-level paging, newer kernel CPUs, user space expands to 56 bits. Okay. So single VMA could theoretically approach 64 bytes. So that would be 5-level paging. Each line in procpid maps corresponds to one VM area struct in the kernel. Okay. Yeah, I'm leaning towards just doing the thing where it's like each map has its own sort of page table type concept. But it's like how do we have a dynamic leveling? Because this is like fixed level, either 4 or 5 level paging is fixed in the kernel and the CPU. Like how do you do a variable mechanism? Like if there's only one page in the map, you really don't want to waste time with any of this. The optimal thing is just to point at the map. So it's like we have to do some like math up front to determine whether the size of the map. Can maps be resized? I think they can. Can maps be resized at runtime? Yeah. Remap. So we can't do math up front to determine what structure, like how many layers we want for our structure. Because it might, the size of the map might increase, which would change everything. I guess we could reevaluate that every time. Every time we make changes to the map registry, we could redo the page tables for that map. Yeah, I mean, I think I have a pretty decent feeling for what this should look like, but it's like, it's not jumping out of my brain. Like, I have an intuition for what needs to be done here, but I don't have an eagerness to want to start implementing because, I don't know, my brain's just like, oh, this is going to get complicated. So maybe for tonight, instead of approaching this problem, which is probably the most pressing problem for the project right now, and of significant complexity, maybe I pick something a little bit easier to work on and let the ideas kind of like continue to develop inside my subconscious mind. And then take a crack at it maybe tomorrow. Yeah. Well, let's get a commit done here, and then we'll talk about that. So I think that's about it. So we have add arg parsing, debug translation units, refactor map registration, and read maps. Refactor map registration and read maps from PID from PID. Git CI that. Oops. Git CI. I'll just do that. Yeah. Git cat file. Oops. -p. That. Git push all. Oh. Okay. Okay. It's very clear. Status. Okay. Let's do maybe our main here. So we set up our arg struct and we call parse args, giving it our argc and argv and our arg structs. Now we got our args. This thing set config flags. What does this thing do? Set to try enabling MSAA4X. What the hell is that? I don't even know what that is. MSAA4X. Force 4X MSAA multiple sample for anti-aliasing. There's a graphic setting found in Android's developer options when enabled to force your GPU to process 4 samples per pixel. In OpenGL ES2 apps, smoothing out jagged edges in 3D games for a sharper image. However, it dramatically increases battery consumption and can cause overheating. Well, we're not mobile. Before calling a net window. frame buffer object to handle the multi-sample buffer. As Raylib standard load rendered texture does not support MSAA out of the box performance, while MSAA 4X provides great visual quality. It places extra load on your GPU. On less powerful machines or mobile web exports, consider disabling it or dropping to 2x if you notice a drop in your frame rate. For quick, can this setting be toggled at runtime inside of a draw loop after the window was already created? Doesn't seem like it can. The screen restart method, hard or MSAA. Okay, to change the hardware setting mid-game, you must completely tear down and recreate the window because this destroys the OpenGL context. You must also reload all of your texture shaders and fonts. Okay, so you just go close window, and then you can then set the flags or not, and then you initialize the window again. Okay, since this is very much like window related, I'm going to move this into the create window. It should be under window.c. So it'd be up here. Oh, I need to order these together, right? If I am also giving this, will I need to OR these together in Raylib? Yeah. Unsigned int flags. This is just an int. And these are typedef enum. Hex values. Yeah, I'll just put them in the call like this instead of worrying about that. Okay. Instead of tests, we'll say virtual memory visualizer. I think it's a Z, right? Visualizer. Yeah. If I did this, it'd be like, no. Okay. Let's see what that looks like. Okay. I had a bunch of memory allocated in this process. So I'm going to quit that, And let's just do another. There we go. That'll be less memory. It is a pretty neat thing to see. One thing I do need to do here, it says get et al. We'll just say fixware config consolidate raylib config flags. One thing I did want to do here is set up the communication between the two threads for telling the synchronization thread, the main thread needs to tell the synchronization thread what pages are currently being viewed. Active pages, I guess you would say. And it's interesting because like that could be, I think the best way of doing that is just like having a buffer that is null terminated and just handing that buffer off between the threads. Because the structure that is synchronizing the data is a pointer to a buffer and a mutex that locks operations on that pointer to the buffer. When the UI thread wants to tell the other thing what to do, it's going to either reuse the same, take out the lock, reuse the same buffer, and then if the buffer is not big enough, then it's going to allocate a new buffer and free the old buffer, like do table doubling basically. So what do I want to call that? I think, so if we go under here, draw.c is going to be the thing doing the computation on what pages are visible. So here, draw page cells, if we get to there already, we know, okay, draw page cells. This buffer is no longer going to be a thing. Buffer length. Maybe we can pull that out. I don't know. The zoom threshold, is that being used multiple places here? Yeah, I guess it is. So say, hey, if get zoom is less than the zoom threshold, it means you're too far out and we're not going to draw anything. But to do add page or mark page as active, say that maybe. So this buffer thing, we're going to have some other type over here, which is going to be a it's going to be like the map page table. Page table pointer page table. This will be page table T. And we're going to need to include our page table.h. And then I'm going to edit include page table.h. And here pound if not def page table h, then we define and then end if. And here we're going to say well, we want our struct type def page table T, and in here it's going to be something just that to do. Okay, and then in our map.h, this is also going to have a page table for the map. So now we're getting into doing the page table structure. I'm just going to stub that out here. Page table.h. The map is going to have a page table T pointer PT for page table. And if we go back to draw.c, we're going to have to pass that down into here. This is also going to need to do remove buff and len use page table. Then we're also going to have a active page reporter, page active page notifier. Notifier pointer page notifier. Say here, I need a name for a type that is responsible for communicating between two threads what pages are active. The main thread records, takes a lock, records what threads, what pages are active, releases lock. The worker thread then acquires lock and reads what pages are active. Page tracker, I like that. This keeps track of what pages are active. And when a page becomes unactive, we can then also remove it from the page table, the multi-level page tables. So page tracker active page notifier. I kind of like that. It's a bit verbose, but does what it says on the tin. I'll keep that. Okay. Include active page notifier. The H, and then we'll do the pound if and def, and then this will be underscore active page notifier H. I don't like that they put that there. Define. Okay. Type def struct active page notifier T. Down here, active page notifier T. And then eventually we're going to remove this thing. Bam. We might as well just remove it now. Buff. To do. Draw cells from page if possible, else placeholder cells. There we go. And that's just for the text. So what I'm going to do here is I'm going to continue to do this. Not the buff. This will be actually we'll just say text here is dash dash. Can I build? No. So the buff and the lens stuff, buff here. These can be null null for now. To do fix nulls. Okay, active page note. Empty struct is a GNU extension. Okay, page active page notifier. In here, we'll just say like int x, int to do. We'll do that. Bam. And then we need the same thing with page table. Page table h int to do. Okay, I get that from completing. And now we got len. So that's gonna be map. Sorry, draw. See. So now we need this len. So len's gonna be a const. Page len. This is page related. I'm gonna put it up here. And we'll say the page is, sorry, that big. 1 UL bit shift over 12. Yeah, because it's draw page cells. It's a specific page. Every page is 64 times 64. They go over here, Python, 64 bytes times 64 cache lines, or I can do 112. So that's what I did up here. So this would be, instead of len, we're just going to use the const page len. Okay, that fixes up that. There we go. And then we'll just get our dashes in here instead of zeros, which is fine. Okay. So let's continue on. So we gotta fix these nulls. So we need to have access to the map here. Drop page. So the buff and len are obviously not going to come in here. We're going to have to take in these arguments here and pass them through. Oops. There we go. So now here, draw page. Map buff. Page number is I. We're going over pages. Pages is computed by looking at the length of the map. Length we will have, the length of the map. Buffer we will not have. So if you go back to map here, sorry, map.h, we're going to remove our buffer. There we go, just delete it. And I'm going to reorder these to be remote adder length, next page table. Okay. Page table is associated with a map. Yeah, okay. Makes sense. Okay. So now let's go back to draw.c. And anywhere we have buff is obviously going to be problematic. Here. So map buff, basically you don't want to send that in. Page byte size. Do we even need to compute that? I feel like that is constant. So I have this value twice now. I have page length and page byte size. So I'm going to do away with that. Page len. It's now page byte size. And I want to do a bit shifting up here, which would be 1 UL bit shift over 12. There we go. Okay, and here, getting rid of this and this. So this is now draw page, and we got to give it the map page table, and this other value, null. To do so map page table, sorry, this would be root pt. Okay, we got errors now. Unused parameter pt. Well, that's fine. Is that a warning? That's a warning, right? Yeah, it's just warnings. And within or, place parentheses around and expression to silence this warning. Okay, that's just okay. We'll fix that. As in draw C 239. 239. These aren't required, but I guess the compiler is like, oh, it's precedence. It's confusing. Okay. Make clean. Okay, so we got unused parameters is fine for now. Comparison of integer of different signs, int and size t. So that was under all map.c 257193. Map.c 21. So 257193. 2572. Invalid application of size of to a function type. Oh. Map monitor args. Should be like that. I don't know why it was being called like a function. Allocation of instance size 1. Size 16. Okay. No member named buff instruct map. Buff. Okay, so we don't need to allocate that anymore, which is great. Okay. Let's do make clean, just to catch our warnings. Okay, there we go. Zoom, 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 zoom. See everything, cool. All right. We saw these warnings here. Let's see if I get the compiler to fail on warning. Can I get Clang compiler to fail on warnings? W error. Okay. So that'd be a make file change for warnings. W error. Wall extra error. Okay. So now we go over to our draw C, and then there's this draw cells, page cells. We gotta use these arguments. PT auto underscore is equal to PT. Can't do that. And PN. Oh, it's still an unused variable. I think I can assign it to globals, right? This will be these types here. This will satisfy the compiler. It is kind of silly that I have to do this with that setting. Oops. There we go. I have some warnings for args that are unused. How do I silence this the warning now error for this one function without disabling warnings or errors in general. In Go, I can just assign things to underscore, but this compiler wants me to assign to global variables for side effects. Okay, and then we got this last warning, which is comparison of integers of different signs, int and size t. So that's map C. Line, what line was it? 26 again. Okay. No, it's this one up here. So n, what is n again? N was the result of sprintf. If n is greater than size of, okay, can I just do that, or say unsigned, or say size t here? Will that fix it? No, because it's gonna be negative. Size t is not negative. Yeah, just do that. There we go. Okay, so you can just say arg void. So let me go back over to, was it draw C up here, and we just say void. Void. If I didn't have these, it would blow up because of that warning. Yep. Okay, that's good to know. Thank you, AI, for that. So here, say to do, use these. We'll say move these once in use. Okay. It changes to do. Boom. Okay. Cool. That is some progress. Let's do get status here and say get restore stage. Get status, get add make file. Get restore stage dot get status, get add make file, get diff, or just get DC. We'll just say make warnings errors. Get status. Get stash. Get, or say here, make clean and make. That's gonna fail because you have those things we need to fix. Don't want to just fix those. Yeah, let's go ahead and just fix those manually. I guess I can do git stash pop. So this is draw 231, 232. Restore staged. Okay. Git add p on, what file was this again? Draw.c. So no on that, no on that. This is the fix there. Git ci an. Amend. No edit. Git status, git add all, git stash. Make, clean, make. Okay, so now we have this problem there, which is in map.c. Git stash pop. Git restore stage dot. Git add p is under source map c 71. Yes on that. Yes on that. No on that. Git ci amend, no edit. There we go. Git add all, git stash, git status. Make, clean, and make. Look at that. Pew, pew. Git stash pop. So now we do our next commit. Git restore stage dot. So we want to do now. So you have all this stuff with like the page table being introduced, the buffer being removed. Git add all, git dc. So we're adding the concept of a page table and a active page notifier. Oh, this removed null here. We need to fix that. So draw.c, remove null. So how do we want to get our notifier? How do we want to hand off our notifier, I guess? So draw map comes from draw maps, comes from the draw loop. And the draw loop is completely independent of the other thread in main. The start map monitor. So the start map monitor has a registry which is strictly used to display maps. That's the map monitor. So really what we want is like a page monitor now. So we have a map monitor, it's monitoring procpid maps, updating the registry based on a PID. And then we have a second thread, which is the page monitor, which is monitoring active pages and updating the page table structure for a specific map, though. And when the map gets a resize, so we have to handle that. Start map monitor, so that'd be under what? Where does this thing come from? Map H, map.c. Here. A register map, I guess. would be where we would do this. To do handle map resizes via mmap remap? Remap? I forget the name of this. Man remap. Man mmap. Remap. Removed. What is the name of the... Is there C also down here? Unmap. Unmap's easy to detect. We'll have to do that as well. So we need to handle unmaps. What is the name of the... let's go here. What is the name of the syscall on Linux to resize a memory map? Remap. Man remap. Remap and handle map deletions via unmap. Alright, those are things I'll need to do at some point. To be honest, like I really don't like these linked lists. I like the table doubling, array table doubling. It's like amortized O of 1 for access. The difficulty is in insertions, whereas a linked list insertions are O1. You gotta do more movement of data when you insert things. I guess maps can be inserted, they can be deleted, so insertions and deletions. Like right now, insertions get added on at the end instead of where they should be. So that's a problem. So I gotta do some work here to handle insertions, deletions, and resizes. Okay. So where am I? Where I got a little lost here. So, well, let's go back to terminal. We were doing the last draw thing to pass through the active page notifier. That was our goal here. So map.c and main C. So we need to do a start page monitor. So you have a map monitor and a page monitor. Page monitor is going to take in the active, we call it PN, for page notifier, and it's also going to need a page table, PT. So here we're going to have to set up that state. And then the draw loop is going to have to also take in a reference to PT and PN. But the page table is local to the map. We're not doing a global page table. Okay, so when we go in here, this thing is going to also receive the active page notifier T pointer page notifier. Then this thing also has to go in here, page notifier. Draw maps is going to have to take in the active page notifier PN pointer. If we go back over to our header file, which would be draw.h active page notifier T pointer page notifier. There we go. So in here, we have draw maps, draw a spacer, that doesn't have a page notification, then we draw the map itself, which the map page notifier, map cursor page notifier. And then down here, that gets passed in here. This is called the Y cursor, so draw a map here. Y cursor. Draw a spacer should also use the same terminology. Yeah. And I like the positioning of the cursor to be consistent, so I'm going to put it at the end here. Which means in here, it'll need to be at the end here. Okay. So start page monitor, we need to set that up. So if we go back here, we had start map monitor. Map.c has the start map monitor. The page monitor should be in the active page notifier. I think maybe here. Oops. Void, and it's going to take in what? A registry and a page notifier. Oh, this doesn't need RayLib anymore because we moved that. Include, that's not needed anymore, I guess. Okay, we can put that there. Great. Start page monitor. Start map monitor. Active page notifier. Start page monitor. Registry. Map registry T pointer. Reg. And the active page notifier T PN. There you go. Let's do our build. Alright, we're still getting start page monitor undefined symbol. Okay, that's a linking error. Makes sense. So now we have to edit our source active page monitor dot C. Active page monitor H. Copy this thing over here. Actually want to get a space there. It really isn't this thread. It really isn't an active page notifier concept. It's more of a page monitor. So I feel like let's go ahead and just write everything out. But I'm going to move source active page monitor C to source page monitor dot C, and then touch include page monitor dot H, vim include active page notifier, and I'm going to pull out the monitor and then go to the monitor here and paste that there. Start page monitor. There we go. Active page notifier. So we can delete that now. And this would be page monitor. This will be pound if n def underscore page monitored underscore h, define pam. Okay, and then this needs to pound include map.h and active, map.h like this. There we go. And then over here we can say page monitor C. And I can just do a pound include of page monitor here. Monitor.h to do. Okay. So we have a notifier, active page notifier, a page monitor, and a page table. I do want to split out stuff in map, but I'll hold off on that. Vim include map. Okay. Make clean. Make. Okay, so we got a Vim. Let's go into main.c. We also need to have page monitor.h. There we go. And then this last one is just unused parameters. That shouldn't be the case. Page, oh, because, yeah, okay, just put a to do there. Page monitor. Okay. All right, builds, doesn't crash, good enough. Yeah, these are test maps. Okay, let's go ahead and do a commit here. Git DC. And do a Vim buffer over here. Add page notifier monitor. We'll just say add scaffolding for page sync. Is I spell scaffolding? It's not really scaffolding because scaffolding would apply temporary. Name for scaffolding that is permanent. Structure and source code. Probably like foundation. Yeah. Add foundation for page sync. It's pretty much all this is. So we have our active page notifier. In our draw, we're passing through the the active page notifier into everything. So I'm confused why this compiled if we don't have a pound include for active page notifier. I guess in draw.h we do the pound include. That makes sense. And we probably pound include map.h in draw. No, draw.h. Yeah, okay. I did remove the null here, so I'll remove that to do. Kind of feel like this should be in here. But if it's the only thing in that block, it kind of implies that it's not being used down here when it is. Like the initialization is part of it, so I'm going to leave it out. I wonder if when you exit the block here, does the compiler reuse this memory? Let's ask ChatGPT. When in C, in the above code, when you exit a block inside a function, like the one that starts that calls start map monitor, is the memory for args memory on the stack for args and proc available for reuse later in the function, or is this stack space reserved until possibly to be overwritten by other stack data like active page notifier, sorry, a PN. And see in the above code, when you exit a block inside a function like the one that calls start map monitor, is the memory on the stack for args and proc available for reuse later in the function, possibly to be overwritten by other stack data like PN, or is this stack space used inside of the block reserved until the function exits? And see, the storage for block scope local variables like args and proc becomes invalid once execution leaves that block. And the compiler is free to reuse that stack space later in the function. So in your example, I have to close both objects lifetimes end. Later, compiler may place PN in the exact same stack memory previously occupied by args and proc. A few important details. C language guarantees lifetime semantics, not physical stack layout. The compiler may reuse the stack slots. I need to get undefined behavior sanitizer going on this thing, because this seems like undefined behavior that should have been caught by the compiler. I made some mistake. It's obviously a mistake that I made in reorganizing the code here. Basically, like with the blocks, I kind of want to communicate what the dependencies are between different code. And I forgot that, like, oh, this is like using stack memory and it's going to get overwritten by this thing. The compiler may reuse the stack slots, keep variables and registers, optimize them away entirely, overlap stack storage for non-overlapping lifetimes. So this is valid and common. Big struct A, compiler may reuse same stack space for big struct B. This is one reason our inner scopes are useful in C beyond readability. They can reduce peak stack usage by shortening variable lifetimes. However, this also means that the thread keeps a reference to this proc here. Like if we go to map.c, that proc thing, which is a pointer, is passed into this thread here. So it's going to hold on to this memory, and the memory could potentially be invalidated. But chances are this is going to override the data in args and not in proc. But even so, I don't want to take the chance. Okay. So how do I detect UB like this at compile time or even at runtime? So it's UB sanitizer. F sanitize address. Let's go over to makefile. No omit frame pointer. Let's see if that works to detect this. Clean. What the hell is this? ASAN. So I need the linker to take in those. This is probably not a compiler flag, but like a linker flag, right? Did not detect that. At least not at compile time. There we go. Now we got some address sanitizers going on here. Stack use after scope on address. So let's do away with the scope. Hey, look at that. That would have saved me. Actually, we're gonna go and do git restore staged, git status, sorry, git restore stage dot, and git add make file. Gets, yeah. And then I need to quit that because the make file has an extra space at the end here. Add make file. There we go. Get CI, we'll just say enable sanitizers. Status git add all git stash. And then we do what? Our make clean, make build, bam. And then what else are we gonna do in here? Git stash pop. Then here, git DC. This will be adding the foundation for page sync. I guess I can move the argument parsing back up. Let's do that. Main, sorry, source, main. Let's put that back up here. Boom. And let's go ahead and use that. All right. And then if I do $, get our PID in here. Cool. Right. I think that's good enough for me tonight. Lots of to-dos added to the source code. I have the UBSAN and address sanitizer added into the build. At some point, I'm going to split out a release build and a debug build. But for now, I'm just doing debug builds because I'm nowhere near at the point of like creating a release binary. But yeah, I added the sanitizers, made the warnings errors to catch things at compile time before they become problems. Moved that raylib. It was actually a bug that wasn't doing the, what do you call it? I think it's a bug. If we look at this commit here, git show that, and then if we go over to raylib source, this guy here, this is the function set config flags, and that'd be in this core C file. What's interesting is like this guy, he puts his header files right next to the C files instead of having a separate include directory. I kind of like having it separate. But let's Let's go back here. I want to go to rCore, and this is doing flag set. Selected flags are set but not evaluated at this point. Flag evaluation happens at init window or set window state. So we get flags, we say flag set, core window flags. If we look at flag set here, it's doing an or equals. So it wasn't a bug. We didn't have to or them outside of the call. We could have continued doing what we were doing. But it did put them all in one place, which is nice. So yeah, lots of stuff. And then the foundation for page sync. I guess that's a big change. Having a separate dedicated thread for doing the synchronization that's spun up already. Having well, it needs a block. It's spinning up and then shutting down immediately. But having that thread monitoring the maps and the notifications for what pages are active and the page table. I think it needs no, because the page table is being stored with the maps. So yeah, it's just going to read from the maps directly. So yeah, having that thread foundation kind of set up, I think is going to make it easier for me to implement this. I mean, I'm going to take a stab at it with the direction I'm going now, but I'm a little bit uneasy with 3 threads taking out locks now on this maps data structure. But I think that's necessary because the maps can be resized. So I think it's necessary that all three threads coordinate off of this maps data structure. And then we have one separate data structure to communicate between 2 threads what pages are active. Yeah, I think I'm fine with that. I don't think it'll be a big issue, but we went from 2 threads taking out locks on a single data structure, and now we're moving to 3 threads. So there could be potentially more lock contention between the 3 of them. Also, the other thread, there's 2 threads. When I started today, or when I started the session, there's 2 threads, and one of them was sleeping for 2 seconds. So that I'm a little bit like, the thread that we're adding in now, it could potentially impact. So the draw thread is going to be doing lots of locking and unlocking. And as soon as something takes a lock for any specific amount of time, it's going to impact the frame rate. So I just have to be mindful. Like this thread's pretty much like who cares? Like, it doesn't really matter. It wakes up every 2 seconds, does some work, and doesn't really hold the lock open for that long. If we look here, in fact, so it's called map monitor. So it's this thing here, and the lock is only taken out when it calls into the register map thing. So register map, I guess register map is getting called n number of times for how many maps. It's taking out the lock and releasing it. I wonder if is there data race detector in Clang? Does Clang have a data race detector to detect data races at runtime? Thread sanitizer, T-SAN. So much awesome technology in this. Do I have to link against pthread? I pound include pthread. So I would hope, I guess that I would already have that. Make file. Clean. Invalid argument, not allowed. Address sanitizer is not allowed with thread sanitizer. Okay. So one of these will have thread, the other one will have address. Oh shit. Hey, look at that. We got a data race. So I need to be running this. That's one there. So I got thread sanitizer and undefined. But if I say san equals asan, I'll get the address sanitizer. So I can opt in for it. Let's fix this data race. So it only happens when we start drawing stuff. No, there's actually, if we go down here, so we can just quit right here. Let's open up another terminal, jump over to vmviz, and we're going to go to read main C 27, create window, so read size 8 at was this thing optimized away or something? Main thread create pthread creates 27.3. Read of size 8 at memory address by main thread. So this is the main thread doing a string compare. Mesa key string equals some Mesa hash table thing, gallium. Never even heard of that. Well, you know what I'm gonna do? Since that's 27 create window, I'm just gonna do this and see if I get a data race. So make clean and make, and then this. Okay, great. Pitted 0 registering test maps. It's just create window, destroy window. That should have no problem. Yeah, see, this is like a problem with the raylib. This is none of my code. I can even like comment out all of this. Yeah. I am running the thread sanitizer on a raylib program. It is barfing on a super simple, I should say, super simple raylib program, and it is telling me there are data races. Oops. Yeah, okay. Is there any way I could just have the thread sanitizer not sanitize raylib code? Since I assume these data races aren't valid, or data races are benign. I only want to detect data races in my own code. Best option, use TEDSAN suppression file recommended. tsan.support. Then run suppression. Okay. So we'll do this then. fsanitize ignore list. tsan ignore.txt. Actually, we'll just say sanitizer ignore .txt, and we'll just add this to all of them. This will just be san ignore. Mesa libgl. It says under user source debug Mesa build. Mesa source, is that an actual user source Mesa? Sorry, debug Mesa. User source debug Mesa. No, it's not on my machine. I think that's probably dwarf information, maybe, that is in the shared object for raylib. Because if I do an LDD on build vmviz, it's dynamically linking against raylib here. So I think that's probably just whoever built Raylib. It's not my machine. Unless, did I build it locally? I don't know. Okay, well, let's try getting rid of some of them with that ignore list. Make clean and make. Okay, it's still barfing out on this Mesa. Cat san ignore txt. Jesus Christ. Okay. Why is this not working? Can I do an echo on all this? Oh, because that's a space. I hate makefiles. Alright, main C draw loop. Hey. So this is a data race. This time it's in SI buffer get transfer. tsand ignore race. So this one is TC buffer subdata. Okay. Next one is TC buffer map. Hey, another one. This is under CSO set samplers. tsand. I wonder if I can do race star, TC star, SI star. I don't think that one's needed. Mesa star. Upload binary raw? What the fuck is that? Okay, it's not racing anymore on that. I just want to catch races on my own code, not all this library crap. So it's not racing on that, but now I actually do want to create a race to test that the race detector is working. So let's go under, let's see here, main. So the thread that we have here is start map monitor reg, and then so if under reg, let's just say map.c. Let's just say we take out our mutex a little bit late. Say we take it out. Or say we don't even take it out at all. I think that won't compile because of the unlock label at the end of the function. So I'll just say return here. Return. Oops. Okay. So now we got a data race between draw maps, which is under what? Draw.c 247. Character 18. So it's accessing, it's reading next. It's doing a read. Yeah. On this next field. And the previous write was in register map. Map.c 96. Here we go. So we're writing into it there. Yep, exactly what I wanted. So let's put that back. And if we look back at draw.c, up here, to do, refactor this to not take the lock outside of in this module. It'd be nice if I could just iterate over the maps without having to take out the lock explicitly here. Because I'm going to need to iterate over the maps here and then in the other thread as well, the thread that's monitoring the pages, the memory pages. So the iteration is going to have to happen in multiple locations to make sense to factor it out. But I also like keeping all the locking code in the same module, same translation unit. So I'm not littering locks. It's kind of, I think it's called law demeter. Like I'm reaching into the register state and locking it for it. The register should just be able to lock itself. It should just be telling, not, was it ask don't tell or whatever? Or tell don't ask? I forget the name of it, but anyways. It should be reaching into the registry here. The thing I want to do is just draw a map. So it'd be nice if I could just hand it a function to invoke on every element. Something like that. We'll see. Just add it as 2 here. But now if I do another make clean and make run, should be no data races. Cool. So I had the address and undefined sanitizers with the no emit frame pointer. And then the sans gets initialized to undefined no emit frame pointer because that's useful everywhere. And then if I ask for asan, then I can get address sanitation. Otherwise, it defaults to thread sanitation. Sanitizer. And then I have a run thing that pulls in the tsan options when I run. So I guess I could make the makefile a little bit more complicated here. by doing a similar test here, but I'm not going to do that. We'll just say add going to get one address, one sanitizer using that. I think probably what I'll do is to do that. Okay. So our normal dev will have san equal to tsan. This will have san equal to asan. ubsan we're never going to really use, so don't need to build that. And then here we just leave the sanitizers off. Okay, and then up here we're going to have run.dev, which is going to do that. And because it's dev, it's going to have tsan. And it's going to do build vmviz.dev. This guy now, the run.asan. .asan will just run asan like that. Run.dev, run.asan, and then run maybe. Sorry, that. Okay, so we got run. I'll call this tsan. Tsan dev. Tsan. Okay. Make run.tsan. So that's going to give us our thread sanitizer. If we go up here, we can see that omit frame pointer. I don't see thread sanitizer anywhere in here. So that means that didn't work. So it probably means that jobs, quit out of this, jobs, kill that. Then make file probably means I need to export here. It's probably because this thing gets evaluated early. Fix my make file to get asan and tsan targets building correctly. No. I think the thing that it said earlier I liked the idea of, which is to say, instead of doing this stupid shit, we just say if we're building vmviz tsan, then we want to say make build vmviz. No, that doesn't work. Because that's just going to make it with the sanitizer. options here. Where's C flags defined here? It's being used, but it's not defined anywhere. Yeah, these guys are a bunch of jokers. I'm just say other here. We'll pull this out. Like that. Sans here, we can remove. Binaries. What is this thing being used for? Oh, all. Build vmviz dot tsan, build vmviz dot asan. To be honest, like I don't want to do separate targets because then I need to have separate object files because object files have their own stuff. I just want these phony targets to rerun the make file. I think that, yeah. So we'll do it up here. We'll add it back. Sans. Do I need omit frame pointer in the linker? Okay. So it's not needed in the linker. Oops. Clean build it, then have a run tsan, which is going to be make build vmviz, which actually will not be here. And then san will be tsan. And then we also run it like that. Asan. This one doesn't need that. And then the regular run, we then run just a regular binary. We don't even need to run make separately. These things are fine. These can go away. Okay. Make run. So this should be without any thread sanitizers. I do get the omit frame pointer, but nothing else. Make run dot tsan. So that should have given us thread sanitizer and undefined. And then if I run asan, it's right here. I guess I can do a ubsan here too. Oh, because this stupid thing here, yeah. Let's delete that. Effectively delete the whole thing. Okay. Make run ubisan. So that should give us the undefined behavior, but nothing else. Make run asan, address sanitizer, yep, and undefined behavior. And then make run tsan. And that gives us the thread sanitizer and the undefined. And then I just do make run, just gives us the omit no from okay. Yeah. Okay, I think that's good enough. Run asan, run tsan, run ubisan. All right, I think that's enough for tonight. Make run tsan. Make run tsand dot dot. No, I can't pass in args. Alright, we'll try this one more time. Is it possible to pass args to a make target? Alright, one more thing, which will be dollar, oops, dollar args. I don't think that's taken already, right? No. It's all the run stuff. Hey, look at that, it works. Alright, so that'll allow me to run, just say make run tsand args dollar dollar. And then if I ever want to switch to address sanitizer, I can say asan here. I think it's a little bit too verbose though. I think what I want to have is like a dev build here, which is dev. It's gonna run run tsand, but it's gonna take a dependency on that. Actually, you know what? I think I'm gonna do the clean. How do I do this? Let's try doing this. Run.tsand. And I want to pass $$ as the args. I don't think I can do that. Okay. Yeah, so as I'm working, I think I can run make dev. I can remember that a lot easier than run tsand, run asand, all that stuff. So I'll do that, and then I'll just do the invocation like this: make dev args $$ when I'm testing things. Cool. All right. That is more than enough for tonight. It is 8:40. I'm gonna get to bed here. But yeah, pretty happy with my progress. I think next session I will be working on. I think the first step I want to do is like have the drawing thread sending the notification to the page monitor thread of what pages are currently active. So setting up, I already have the kind of foundation set up for that, but fleshing that out, getting that fully implemented, that's a good first step. So that'd be my first step. And then the second big step is fleshing out the page table implementation and the rest of the page table monitor and all the locking and synchronization around that. And that's why I wanted the thread sanitizer to be enabled by default as I'm developing, because there's probably going to be some locking issues around that I just want to catch early. I'm pretty good at catching them myself, just having done a lot of concurrent programming. Data races, I'm fairly good at avoiding them, but having the thread sanitizer there is just another safety mechanism to make sure that I don't introduce some weird data race. So yeah, that's kind of next steps for me. And once that's all done, I think I'll be in a pretty good state to record a video just announcing the current progress check-in and putting that on my blog. Because then at that point, it's actually pretty useful, I think, just to start looking at memory of an arbitrary process. It won't be very useful as far as like showing a lot of information. Maybe I'll add some more metadata to displaying the maps, but there's so much stuff I want to do to enrich the visualization, because there's so much information about your program that I feel like when you're diving into the memory of the program, you should be able to have that information easily accessible, like dwarf debug information about what memory is. The ELF binary itself has all this information about the different sections. So you have your segments and then you have your sections. So just having like segments, which are the maps, kind of the information for those segments on the left-hand side, and then on the right-hand side of the maps showing the different segments, I think would be interesting to implement. But yeah, lots of stuff to do. Excited to make some progress on it. But next session is going to be, like I said, getting my feet wet with notifying the page monitor thread with what pages are active, and then implementing the actual synchronization of data between the two processes and all the page table data structure, managing all that. So those are the next steps for this project. Cool. All right, I'm gonna hop off here then. Catch you later. Bye.